Welcome to my Sunday project. Last summer I bought a Marshall fridge for my outdoor room. I expected some sound, but what is this? No sound at all. So I'm a little bit disappointed for a... Let's see if there is a possibility to have this fridge door making some sound. So I open up this so I can take away the door like this. Now it's interesting to see what's behind the panel and this fabric. So I have to remove this, and there are some nails here in the corner. We can leave this, but these ones have to be removed. So I have to loosen them a little bit. Maybe if they're hard, it can heat them up with the hair dryer. But this will work. Save them. And now it should be easy to remove. And here we have the panel. So it's just dummy potentiometers, jacks and switches. So the idea is to make this active, a real amplifier. See what's beneath the fabric here. So take it easy to remove the logo. By the way, the brand Marshall is owned by a Swedish company nowadays. Sound, they made the Marshall headphones, and they recently bought it, a new company. So let's see what I'm going to do now, and further on will definitely void the warranty. The idea is to put real electronics behind this, so I need to know if there are some space for the potentiometers and jacks and switches and so on. So I will check what kind of material we have here. So I make a drill. So it's the depth behind this aluminum plate seems to be about 4 centimeters. So that's good, because then it should not be a problem to make some cavities here, and probably place a loudspeaker behind the brand name. Then we have this Blackstar. I like it. It sounds actually much better, I think, than the Marshall mini amp. It have tone control, but also a kind of reverb delay knob, so it's a little bit more sophisticated. So my choice is actually to try to take this apart and place it here, and we can start with removing the knobs. I can already now check if these Marshall knobs can be used, and hopefully they can do that. Otherwise there are hundreds of these on eBay in different shapes. Yeah, let's see if there are some useful stuff inside this unit. Here we go. And here we have a circuit board, loudspeaker. Okay, try to remove the circuit board. A small board here for the extra speaker and for the voltage. So here we go. And here is the second warning, of course, that when I take this apart it will void the warranty, but it's a fun project, so we go on. So here we have it. Let's see, this is loudspeaker. It seems to be a Class D amplifier here, because it's no heat sink and only surface mounted. So this amplifier has to go with the loudspeaker, I think. And I think I removed this board, and this is the delay reverb knob and overdrive knob and on off knob. I just replaced these with these switches and put this potentiometer in one of these. So I have 4 or 5 potentiometers, so I choose to use these 5 and leave this and try to move this potentiometer behind this panel. So I have to desolder these and put some ribbon cables from this board to the potentiometer, and this is quite easy, this board, because it's only a potentiometer and 2 switches. So I will not use this. The same with this, I don't want to use any external speaker, so it's just from the power supply. So the idea is that I will use one of the jacks for the input from the guitar, and the second I will have for the external power supply. The first thing to do is to try to remove the knobs and so on and replace them with real stuff. So I try to, I think it's just to push out those switches like that, and here is the real one. So I think we have to drill a little bit to have them fit, and here's the switches I got. So I have to rasp a little bit there, and then these dummy knobs, I use this Fein multi-tool. Like this, and then I remove the dummy axis from the knob like this. I say this knob because I need only 5 potentiometers. A couple of the knobs, it was very hard to get out the dummy axis. It doesn't help with hot air or anything, it seems that they are glued together. So I have to drill them. This is 6mm axis, and I use a 5mm tool here and I put some foam to protect. So just drill and then try to pull it out. Nice. As you can see here, now I have drilled this hole so the potentiometer will fit, and I have removed the fake connector here and the switches, which only require a little bit modification to fit in here. So, and the next step is to desolder this potentiometer so I can place them here, and that is the tricky part. It requires, as it is a double-seated circuit board, I have just bought a new soldering station with a hot air gun. I hope that I can manage to desolder this potentiometer, but first it's important to make some notes about these ribbon cables, because I will cut them and replace them longer cables to switches and potentiometers. So I made some notes here. This cable was for external speaker, so the only two connections here are for the power supply. This is for the Class D amplifier and loudspeaker, and this is for this external board. We will not use these switches. It will be replaced by these ones. So by having these notes here, I can cut these cables and start to desolder the potentiometers. So now it's time. I'm a little bit nervous if this will work or I will damage this Blackstar circuit board. Actually, I did some exercise and have, just right for training, managed to desolder one of the potentiometers, and I place it here. It's in this order here: gain, volume, EQ and delay. So I plan to have it in the opposite, so it will be gain, volume or master, EQ and delay for these two. So let's start. I start with to try to remove as much thin as possible, and here is a trick that I actually add some lead based solder, because usually they use pure tin nowadays. It's a environment requirement, but by adding a little bit old-fashioned, I will lower the melting point. When that is done, I plan to use the hot air device here, but that is a little bit dangerous because the axis here maybe will melt down, so I have to cover the sensitive parts with the aluminium plate. So I will go on and suck up the tin here first. I realized that I can cut this outer leg because they are not used in this panel here, as they are with the nut, and that make it much more easier. And then I use this soldering wick. It helps to extract the solder lead. I can see here now that if I move the potentiometer a little bit up and down, I can see that most of the legs will move. And actually, now it comes. There, the second one. That's good. Now the potentiometer is placed in the front panel, and my plan was to make the ribbon cables from the potentiometer to the board. But I realized that I have only this one in stock, so I have to wait a couple of days for a delivery of more ribbon cables. Then was the plan to connect the potentiometers and connectors and so on to the board and check that everything works to destroy something during this exercise. But the next step here is to make a template for make the cavities in the fridge door. I have to remove the potentiometers so I can make this template for cutting out the cavities in the fridge door. I have started to make this template of a transparent for to be in help for cutting out the cavity in the fridge door. So I have these guides here and so on, and then we have to make a cavity or cavities for the switches. So now I will finalize this and then cut it out. So here is the template. It will be like this. Yeah. So now we can see where we should try to do the cavities for jacks and potentiometer and so on. So I have these dots here. Okay. I think there are some and then I have some thought where I should place the electronics, the circuit board and maybe the loudspeaker here, but first I will see what is beneath this surface here. Now it's time for the dirty job. I decided to do a trench here. There I also can dig in the ribbon cable, and the idea is to make a cavity here to stick down the electronics and make a cavity here for the loudspeaker. Next step is to make the cavity for the amplifier. So I plan to slide it in beneath. I love the smell of polyurethane in the morning. I have made a cavity here for the loudspeaker. The problem is to have it, to be able to put it inside this. So I chosen to do an extra cavity here so I can move the loudspeaker in there. This foam has much higher density than I expected. So the problem is that I haven't got the right volume for the loudspeaker. The loudspeaker need in the Blackstar box it's a little bit more than 1 liter. So, but I will place the loudspeaker here and connect it to the electronics and measure it and see how far we are from the same characteristics as the Blackstar box. So now we have it here. Now it's only a test, so later on I will put some nuts here. I have made some temporary connection to be able to measure on the loudspeaker in the fridge door. I have also made a port which I place here, and that's the same size as this port in the Blackstar box. The thing is that when I simulate this cavity, it's actually too small compared to the Blackstar. This is a half liter approximately, but I should need at least 1 liter, which means that I have to remove this foam until here to have been able to have the same response as this box. But I wait with that and see what I have and see if everything works. So I do that before I go ahead and make my day. So I prepare for this and put this cover in here. I have also drilled a couple of holes here so I can fix the loudspeaker later. I don't do that now because if I need to remove these rivets, it's a little bit hard to remove. And then I fixed this cover plate with some tape. The ribbon cables are in place here, and the power supply is connected to the second jack and go through the main switch here back to the card. I use external power supply here from Luxor Parts, and it have a switch for voltage between 3 volt and 12 volt, and I use the 7.5 volt settings here, and it can deliver 1.5 amp. So and then I cut the original connector and put in this connector so it fits into this. One note is that what happens if I put this connector in the wrong jack. The thing is that the circuits here are very well protected, so there is a capacitor which block the DC here, and it's also protection diodes and so on, so it can take even if I connect something wrong. The same with the input, with the power connection, that's also well protected. So it's a polarity protection here, so even if the power supply is the wrong polarity, it will be blocked, and it's a overvoltage protection in this stabilizer too. So it's no risk if it's something happen with the input. Some notes about the wiring. It's a good practice to connect ground to the inbuilt switch for the input jack, so the input will be grounded if the plug is not inserted in a jack. Then the amplifier will be quiet. I also have put a grounding to the housing of the potentiometer that avoids hum when you touch the knobs on the front panel. So this is connected to a ground terminal here. Yeah, I've just cut away with this piece of the fabric, so all the cablings can fit here into the cavity. So now I have to try to find the best way to fix this. I can use some glue, but I test everything fits first and try the amplifier there, and then put the panel like this and put back the knobs here. So, and yeah, there was some decoration here too. Ah, that must be first, of course. Okay. So now it's ready to put back the nails or rivets here to lock it and test the amplifier. Guitar.